is that one segment or part of mathematics, I'll say, which you were scared of when you started initially?
Well, that's every single part of mathematics. When I started algebra, I was scared of calculus. When I started calculus 1, I was scared of calculus 3. When I started calculus 2, I was scared of differential equations. When I started calculus 3, I was scared of partial differential equations. Now that I've finished real analysis, I'm scared of topology. You always feel scared when you're diving into the next thing. But in the end, you're going to understand and work out everything fine.
So Vernon is the recipient of the Global Child Prodigy Award from Nobel laureate Kailash Satyarthi.
Since you all are business majors and not math or physics majors, there's really no difference. Most of you have been conditioned to not really ask questions, to not actually understand what's going on, but just to accept what's happening and what your teacher is telling you face value without questioning. Why is this true? Is this actually true, and what is the reason behind it? You should look into the derivation instead of just reading the theorem and thinking, yeah, I have to memorize it. And before you go saying, whoa, the derivation, that's 15 lines, that's a whole page. How am I supposed to memorize that much? You don't. You don't memorize all the equations that go on behind the derivation. That's just going to lead to unnecessary stress. Really, when you're looking at a derivation, what you want to understand is not every single intricate little detail, not every single little addition and subtraction. The steps should follow naturally to you. You should be like, well, I know I'm here right now and I want to get there, so I know what steps should follow naturally in order to get from point A to point B. In other words, pay attention to the broad strokes. What are the major tricks? Most theorems and proofs only have one little trick behind them that makes them unique. All you have to do is figure out that trick, and soon enough you'll be able to do it on your own. The little details are just something you can do for muscle memory. What you really should be paying attention to are the broad things, tricks that you have to execute, the actual concepts behind what you want to learn. So, since you guys are business majors, most of the math that you're probably learning is related to statistics or differential equations or something in that vein. But these things apply all the same. Mathematics is incredibly important in economics and business, especially in terms of game theory, which itself requires lots of proofs and understanding. And so I predict most of you here will have to go through a lot more mathematics before you're finally able to earn your degree. So I hope you just take this advice at face value. Just focus on the broad things. You don't have to focus on the little details. The muscle memory will do that work for you. You can already figure out what to add and cancel out at every step of the way. You aren't 5 or 6 years old. You can figure this stuff out. You've already done algebra. What you really need to pay attention to are the major tricks that go on in these proofs. We assume that this expression is set to 0. We use this theorem and that theorem to get to the conclusion. And once you understand the major things going on behind the scenes without paying attention to the minor screws, then you can go off and finally feel like you understand the concept. That's just my experience with mathematics, but I hope it has enlightened you a little bit. And once again, don't be afraid to ask questions. I actually had 2 events today. The first was at the Thakur College of Science and Commerce, and the second was at an associated institute, but it was for elementary schoolers. And the elementary schoolers were asking questions nonstop, even if they weren't in terms of math and science. But the college students, and these were just first year or second year level, they were completely silent. They had not a single question, even though I knew this was either on their grade level or it was far past it. So I doubt that 100% of them understood 100% of the concept. So that's why I think most people, as they get older, don't ask questions as much. But your teachers really need to know what's going on in your head. They're meant to teach you, not laugh at you if you get something wrong. So they really have to know if you don't understand something. don't cover something twice if you don't tell them, I need you to cover this twice. It's not like they can read your mind. You have to tell them, I need help on this concept. So don't be scared to ask questions anymore. No one's going to make fun of you. So that's just my general advice for how to approach mathematics. Thank you. And I hope this has been a little bit of enlightenment to your day. Okay.
Remember formulas.
Don't really like memorizing formulas, but when you have to, if the derivation is a little bit too long, usually it just comes from intuition. Most equations that are so long that you can't possibly keep them in your head, those equations, usually you don't really need them to solve a problem. You can find some shorter, more clever way. You can find a better trick to use than using this long equation string. And one more thing, in real life, when you're doing your job, you can always use a reference. Just because you are taking a test and you can't remember this huge, bulky formula doesn't mean you won't succeed in real life. And that's why I encourage people to always use reference tables on their exam. So I think that even though it helps to recall them from memory, sometimes it's better to recall them from the derivation. And if you can't do that, then just look at a reference table if they're too long to keep in your memory. That's just my personal opinion, but I'm sure there are lots of exercises out there if you can't really keep hold of things. There are a lot of exercises out there by like certified psychologists to hold your memory. So I'm not an expert on how to do something like that, but I'm sure that there's something you can do if you just have to memorize this formula. You don't get a reference table or anything.